Hi, I'm Audrey, and today I'll be discussing EEG and neurofeedback therapy, specifically how EEG is used throughout the therapy process, from assessment to real-time training to outcome evaluation. And most of us understand EEG as a tool for measuring brain activity, but here it's used as a tool for training brain activity. So the basic idea is that the brain can receive real-time information about its own electrical patterns. It can learn to change those patterns over time. So today I'm going to walk through how neurofeedback works, how EEG is used at each step, and how this approach applies to certain conditions like autism, PTSD, anxiety, and more. So for an introduction, the purpose is to introduce neurofeedback as a therapeutic application of EEG for brain self-regulation. Some of the big ideas I'll be talking about is how EEG traditionally measures brain activity, and neurofeedback is using this to train the brain. It is a form of biofeedback, but the feedback source here is the EEG activity itself. Now, neurofeedback allows individuals to consciously and subconsciously modify their brain patterns to achieve healthier states. So how does this work? The EEG captures brain activity in real time, and that signal is processed and translated into immediate feedback. This could be a tone or some sort of interactive game. And when the target patterns appear, and this could be increased sensory motor rhythm, reduced theta, or whatever it is that we're looking for in the particular patient, the system rewards the brain. And throughout repeated feedback, the brain learns to sustain these beneficial patterns. So why is EEG central? This gives us great temporal precision, which is important for the operant learning that's happening here. It's non-invasive and reflects direct cortical activity, and again, enables that real-time closed-loop feedback, which is essential for training the brain. So for the foundations of neurofeedback, again, this uses real-time signals to teach people how to self-regulate brain function. It is rooted in operant conditioning. Rewarding desired EEG activity increases its occurrence. Over time, this reinforces stable, efficient neural firing patterns. So in this feedback loop, the EEG records continuously. The software filters and extracts those frequency bands of interest. And again, this depends on the patient. The participant receives the feedback, and that positive feedback helps reinforce the pattern with that desired state of the brain, whichever ways we're hoping to see more of. And the repetition of this over time strengthens the brain's ability to enter that state more voluntarily. So for step one, this is where assessment and protocol planning happens. And this process begins oftentimes with a baseline EEG or QEEG, and this is sometimes called a brain map. This gives us a nice baseline to start out with. This involves recording resting state EEG while the client's eyes are open and closed. Using quantitative EEG analysis, or QEEG, clinicians evaluate spectral power, coherence, connectivity, and asymmetry patterns. These metrics are compared to normative databases to identify the areas where brain activity might be dysregulated. So for example, some regions may show excessive slow waves, heightened beta, abnormal coherence, or unusual asymmetry. And these findings guide the development of the neurofeedback protocol, determining which brain regions should be trained, which frequency bands should be targeted, and what thresholds should be used. And this step here is the core process of neurofeedback, where EEG becomes interactive. And during each session, real-time EEG is recorded from the selected sites. The software filters the signal to isolate the frequency bands of interest. The system then calculates EEG features every few hundred milliseconds and compares it to the training thresholds. When the brain produces the desired pattern, the participant receives immediate positive feedback. Again, for example, a movie could play smoothly, a game character moves forward, or a tone sounds. When the brain shifts away from the desired pattern, that reward just pauses or changes. This immediate reinforcement enables the brain to learn what internal states are associated with success. And then over repeated sessions, the brain gets better and better at sustaining those healthier activity patterns even outside of the neurofeedback environment. And step three, this is where monitoring and adjusting happens. So throughout therapy, EEG is used to continuously track progress. So clinicians review session data to see how often the client is meeting reward criteria, whether EEG patterns are trending in the desired direction, how stable or inconsistent certain rhythms are, and whether artifacts like muscle activity or maybe eye movements need to be managed. And then based on this, the clinician may adjust thresholds, shift frequency targets, or change electrode sites. So this is ultimately a very adaptive process, but it ensures that training remains effective and individualized as the client's brain learns over time. And then we have step 4, which is the post-training evaluation. So after completing several sessions and going through the neurofeedback program, the post-training EEG or QEEG is performed. This is done under the same conditions as the baseline to allow for a direct comparison from the beginning to the present. And then these EEG improvements often correspond with clinical changes, just depending on the patient, like improved attention, better emotional regulation, reduced anxiety, or improved sleep. So it not only guides the training, but EEG also helps us verify the outcomes. So just some clinical applications where we see neurofeedback used very commonly. These 5 have growing research support, and I have seen them personally in my own experience working at a neurofeedback clinic. 1, autism spectrum disorder. Neurofeedback aims to improve attention and reduce dysregulated connectivity patterns. So a lot of individuals show improvements in focus, communication, and emotional regulation over time. And then next, in PTSD, these protocols often target calming the hyperarousal network by increasing slower, more stable rhythms. And here, neurofeedback has been associated with reductions in reactivity, reductions in intrusive thoughts, and improved emotional control. For anxiety disorders, it works very similarly, and clients often report reductions in physiological tension and improved mental quietness, so they just feel calmer. And then we have traumatic brain injury, and this one can vary a lot patient to patient, just depending on the injury, but training can improve neural efficiency and coherence in regions that were affected by the injury. And outcomes can include better attention, cognitive speed, and reduction in fatigue. Again, this just depends on the original injury. And then sleep problems. And this one, since there's so many different sleep disorders that could occur, these results can vary a bit just depending on the person as well. But by training more stable and regulated rhythms, neurofeedback can help improve sleep onset, reduce nighttime awakenings, and enhance overall sleep quality. Just so some evidence, limitations, and the future. We see a very strong base for ADHD, epilepsy, and insomnia. And the evidence is very promising for anxiety, PTSD, autism, and TBI. But these ones typically require more sessions over time for the effect to be noticeable. But like I said earlier, the effect still happens, and a lot of patients see positive outcomes over time. There are some challenges, though, with this. There are heterogeneous protocols, which is a good thing since the treatment is individualized, but it is a challenge in itself. There are variable control conditions and limited standardization of EEG biomarkers for treatment selection. But some emerging trends are coming around. First, we see AI-driven adaptive neurofeedback, which is a future possibility. Also connectivity-based neurofeedback, so this is a network-level training, and multimodal integration, all of which are interesting possibilities that are still being explored. And then for a conclusion, just to wrap up, neurofeedback is a very powerful example of using EEG, not just for diagnosis, but for active modulation. So EEG is involved at every stage, including the initial assessment, guiding the protocol, providing feedback, tracking process, and tracking their progress throughout the process, and in evaluating outcomes. Additionally, neurostimulation used between QEEG sessions can be used in conjunction with neurofeedback to enhance these effects by priming the brain for more effective learning. So neurostimulation can be a helpful tool to use in conjunction with this as well. So ultimately, neurofeedback allows the brain to develop new regulation skills through practice and reinforcement, using its own electrical activity as the guide. Thank you.